Chapter 5 Gases 5.1 The Gas Laws. In this chapter, we will study the behavior of gas. We will find the relationship between gas temperature, volume, pressure, and the mass of gas. Let's begin. Aerosol cans. These cans, pressurized containers, contain gases at high pressure. Under the sun, the temperature of the can rises, and so does the gas inside. So what may happen when the gas temperature increases? 1. Pressure. Refer to the picture below and recall your experience. You may tell that it is not force that cuts, but it is force per unit area that cuts. In other words, it is pressure that cuts. Pressure is the normal force exerted per unit area given by P equals F over A, where F is the normal force exerted on the area. The unit of pressure is PA, which stands for Pascal, and 1 Pascal equals 1 Newton per meter square. Example 1. Bed of nails. We know that a single nail can be dangerous, but standing on a nail bed is not as dangerous as it appears to be, as the total area of the nail heads is not small. The pressure exerted by each of those nails is not that high. In this example, you can see the pressure becomes smaller as the total number of nails increases. A. Gas pressure. 1. Atmospheric pressure. Atmospheric pressure is about 100,000 Pascal, which is 100,000 Newton per meter square, produced only by the collisions of air particles. Due to thermal motion, air particles travel at high speed and collide on our body all the time, and so there is always an atmospheric pressure acting on our body in all directions. Atmospheric pressure is in action all the time. Everything is subject to atmospheric pressure. When we suck a carton of soft drink, the pressure inside our mouth is much reduced. The carton is forced to collapse as the pressure inside is smaller than the atmospheric pressure outside. The following video demonstrates a similar idea.
Fill a metal can with some water. Then heat the can with a Bunsen burner until the water inside boils. Allow the steam to come out of the can for some time. Put the can into a cold water bath. Note what happens to the can. Why does the can collapse?
So what about there's no carton? How do I explain the use of the straw? When we suck, then the pressure inside our mouth decreases. The atmospheric pressure is still that strong that pushes downward, pushing the milk through the straw into our mouth. Another application of atmospheric pressure is a suction cup. When we apply a suction cup, we should first remove the air between the cup and the wall. As the base of the suction cup is elastic, the pressure inside is further reduced when it is pulled down. Since the pressure inside is smaller than the atmospheric pressure outside, the atmospheric pressure pushes the cup against the wall. The friction by the wall on the cup increases dramatically and holds it there. 2. Measuring gas pressure. A boiling gauge is used to measure pressure. When the pressure inside the curved metal tube increases, the tube uncoils. As the pressure is larger, the tube uncoils more, and the pointer is deflected more on the dial. Example 2. Atmospheric pressure at different altitudes. Atmospheric pressure decreases with altitudes, which is height. In other words, atmospheric pressure becomes smaller at higher places. And now you should be able to explain why the bottle on the right collapses when it returns from 4,000-meter mountain. Do check point 1 below.